Welcome to chapter 4. So in chapter 4, we're talking all about quadratics. Now, when I talk about quadratics, what I mean are polynomials that have a degree of 2. So an x squared in the formula. Now, this first box right here, this tells us kind of the basics of what you need to know. So the parent function is always that x squared function, which I know that we've already gone over before in chapter 2 when we learned about transformations, and you've seen these before in Expo. So remember, the basic shape is a parabola. The vertex is going to be that minimum or maximum point, that point right here that creates the axis of symmetry. Okay, now all of these terms you've heard before. In fact, you've heard the terms vertex and axis of symmetry when talking about absolute value. And here they are essentially the same thing. Now, we're also going to learn how to graph these basically the same way we did absolute values. We're going to be using that idea of transformations to graph them. So the form of quadratic that we can graph using transformations is called a vertex form. Okay, where you have your multiplier outside, so that a value. Then you have this x minus h. You have the x shifting, and you have the vertical shifting up and down. So that's how we're going to learn how to graph these, is by using transformations. So as we're going through this, I want to review first and foremost what we learned in chapter 2. All right? So remember, this number out front, that a value that's multiplying it, that we call the vertical stretch. So we have a stretch of 2. Now, the tricky thing to remember, that horizontal shifting works opposite of what we'd expect. So that plus 5 is actually sending it to the left 5 and down 3. This one over here, remember when there's a negative out front, remember we separate, we actually call that two things. That is an x-axis reflection, then that is a shift right 4 and up 2. So it is going to be very, very important that we remember those transformations, because that's how I'm about to teach you how to graph. So when we're graphing in this vertex form, again, we're thinking of those transformations. So the first thing you want to do, you want to make a table of your parent function. So this table that I have right here is showing that parent function, y equals x squared. So negative 2 squared gives me 4. Negative 1 squared gives me 1. 0, 0, 1, 1, 2, 4. So all I've done is I've created that basic x squared function. Okay? So now that I have that table of the parent function laid out, remember the first thing is if there's a stretch, remember we want to incorporate that right away. Okay, so I'm going to add a third column here where I take that x squared and I'm multiplying every one of those values by 2. So remember, that's how we deal with stretches. So a stretch of 2 means I take all of those values and I multiply them by 2. And then I don't even need this column anymore. I'm not going to consider that. I'm going to consider these x's and these y's. So that's what I'm going to plot. So negative 2, 8. I'm going to plot negative 1, 2. I'm going to plot 0, 0, 1, 2, and 2, 8. Right? And you can even see the formation of the parabola happening already. All right? But remember, we need to do the shifting now. So the stretch goes in the table. And now I look at my shifting. Well, I'm going right 2 and down 3. So I'm going to take every one of those points and shift them right 2, down 3. That will land me there. Right 2, down 3. Right 2, down 3. Right 2, down 3. Right 2, down 3. So I have a set of new points now, and those points in blue are the parabola that I want. And this is very similar to how I taught you to graph absolute values. You start with a table, incorporate the stretch, then you shift it around. Now, with these quadratics, there's a lot of vocabulary that goes into these quadratics. So after you graph it, the next thing is interpreting all of that vocabulary that I need you to know. So the first thing is the vertex. Now, the vertex should not surprise you, all right? So the vertex is going to be that point right here, okay? That vertex is that bottom point. So what are the coordinates of that point? Well, 2, -3. So from the vertex is the very bottom or very top of our graph. The axis of symmetry. The axis of symmetry is that vertical line through the x value of the vertex. So remember, I can just use that x value, but to write it as a line, I need x equals 2. All right, you need to have that x equals part. All right, the next part, as a min or max. Now this is also connected to the vertex. So here notice the vertex is the bottom of my graph, okay? It's the bottom of my function. So because it's the bottom means it is a minimum value, okay? So what is that minimum value though? We have to answer not just that it is a minimum, but what is it? Well, the minimum value is the y coordinate of that point. So the minimum is the y value from the vertex. It's sitting down at -3. All right, domain. So remember, domain is connected to x values. So the domain has x values. Now, the cool thing is it's really, really easy here. Okay, the reason I say it's really easy is it's always all real numbers. You can use any x value in a parabola. So every single parabola that I give you is always going to be all real numbers. Okay? Now the range is the y values. And that's where it's going to get a little bit more interesting. So what y values are we seeing? Well, I'm seeing it start at that -3. Okay, you start at that vertex. Now, where are all the values going? Well, I see the values going up from that -3. So because the values are going up from that -3, what that tells me, all of my y values are going to be greater than or equal to that -3. Any y value I can get is -3 or above. And that's how you label all of the vocabulary that goes with these quadratics. And again, every single problem, we're going to be practicing this skill. So you will get good at it. But a very good reference are these descriptions I've done here for you. Okay? I've typed in descriptions so you can reflect back on this as you're doing your practice work. Now, let's do a couple more examples before we end this video, because this does take practice. This is a skill that we have to learn. So the first thing I want to check out is, do I have a stretch or a reflection? And here I see that negative out front. So what that means is I do need to add my third column here. Okay, so I need to take all of these and I'm going to apply that negative to them. Okay, once I do that, now I don't need that middle column anymore. These are my x's and those are my y's, so I can plot those points. So I get -2, -4. I get -1, -1, 0, 0, 1, -1, 2, -4. So I get those values right there. And now I have to go and I have to incorporate my shifting. So this is telling me it's going to the left 3 and up 2. So I'm going to take every one of those points. Left 3, up 2. 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 And now once I've done that shifting, now I make my parabola. So again, I know I've said this probably a dozen times already in this video. Incorporate this stretch into your table of the parent function, and then I want you to shift it around. So we've already described the transformations here. All right, the transformations. There's an x-axis reflection. It went left 3 and up 2. And now we're going to go and we're going to label all of that wonderful vocabulary that we have. I'm going to start with a vertex. So again, that vertex is going to be that top or bottom point. Here, the vertex is sitting with an x value of -3 and a y value of 2. Axis of symmetry. Remember, axis of symmetry, you always take the x value of, oh, I'm sorry, and I underlined the wrong thing. You always want the x value of the vertex. Remember, it is that vertical line that splits the parabola in half, and it's always the x value of the vertex. The min or the max. Well, notice this time it's the top of my function. So it's going to be my maximum point. Now, what is the maximum point? Well, remember that comes from the y value of the vertex, because that represents what the function actually is at that point. So the maximum value that function can take is 2. The domain. We love doing the domain because it's always the same. We can use all real numbers. Any real number can be used. Any x value is possible, is legitimate. And now the range is where it gets a little bit more interesting. So remember, for the range, we look at that y value. So your vertex is sitting up at 2. All right? And I see all the values being underneath it is going downward. So because of that, all of my y values are going to be less than or equal to 2. I'm never going to get that function to be above it. Everything is below that 2. And so that's how I write my function, or that's how I write my range. Now, hopefully you're seeing already. So, food for thought. How can you tell before you graph if the parabola is going to open upward or open downward? Because there is a way you can tell. Now, I'm not going to say this in the video. I want to have this conversation in class. But I want you to think, what makes it go open up versus open down? There is a way you can tell. I want you to think about that. And maybe this last example will help. We're going to do one more example together before ending this video, and then you getting to write your summary, and then come back for practice time. I start with my stretch of 2. So that's going to make a new column in my table. So all those x squared values, I'm now going to multiply every one of them by 2. And now, like I always say, we don't need those values anymore. Okay, once the stretch is in the table, we don't need those original values anymore. Now, all we have to do is plot these. So negative 2, 8, negative 1, 2, 0, 0, 1, 2, and 2, 4. I'm sorry, I forgot to change that one. That should be an 8. 2, 8. So let's talk about those transformations. So I've already done a stretch of 2. This is telling me to go left 3. Remember, it's the opposite. And down 5. So let's take all those values. Left 3, 1, 2, 3, down 5. 1, 2, 3, 4, 5. All right, left 3, down 5. 1, 2, 3, 4, 5. Left 3, down 5. 1, 2, 3, 4, 5. Left 3, down 5. Left 3, down 5. And again, don't make yours as messy as I'm doing. I'm just showing you those lines so you can see where I'm shifting. But you don't have to make those lines. You can just plot the point. So there is my parabola. Now that I've made my parabola, now it's time to investigate all of the vocabulary for the chapter. So the vertex. Where is my vertex? Well, the x value is sitting at negative 3 because I shifted 3 left, and down 5. Axis of symmetry. Remember, you always take the x value. So x equals negative 3. That's going to be the vertical line that cuts my parabola in half. Minimum or maximum? Well, here you can see it's the bottom of the function. So it's going to be a minimum value, and that value itself is always the y value of the vertex. For the domain, remember we love domain because it's always all real numbers. You can use any x value in these parabolas, in these quadratics. And the range? Well, for the range, notice we're starting here down at negative 5. So we're starting at negative 5, and I see we're going up from it. So our y values are going to be greater than or equal to that negative 5. All right, we're never going to get anything below it. The function is only going upward. And that's all. That's the vocabulary that you need. So you've seen 3 really good examples of how to graph these. So what I want you to do in ending this video, I want you to reflect. Describe for me what you're taking away from this video, how you are going to remember how to do this process. Because that's the big thing, is remembering. You have a lot of vocabulary, all of it fits together, and I need you to make those connections. So write about how you're going to remember, what little tricks and mnemonics devices you're going to use to remember that vocabulary. And then come back as always ready to do your practice work.